Materials have captured our imagination with the potential to show properties and activity that we've never seen before but equally have captured our concerns. Researchers have created a new AI algorithm called talk clustering, which is much more similar to how natural intelligence works compared to existing methods. This new approach greatly enhances the ability of AI systems to learn and find patterns and data all on their own without needing help from humans. Talk clustering can quickly and independently analyze huge amounts of data in various fields like biology, chemistry, astronomy, psychology, finance, and medicine. It can help discover new things like identifying disease patterns, spotting fraud, or understanding human behavior. Professor C.T. Lin from the University of Technology, Sydney stated that animals naturally learn through observation, exploration, and interaction without direct instructions. And the next generation of AI, called unsupervised learning, seeks to replicate this process. Most current AI technologies depend on supervised learning, which is a training method that requires humans to label large amounts of data using specific categories or values so that the AI can make predictions and recognize connections. However, supervised learning has its drawbacks. Labeling data can be expensive, take a lot of time, and is often not practical for complicated or large tasks. On the other hand, unsupervised learning operates without labeled data, allowing it to discover the natural structures and patterns within datasets. Method and features of talk clustering. A new paper detailing the Torsia clustering method has recently been published in the prestigious Transactions on Pattern Analysis and Machine Intelligence, a leading journal in the field of artificial intelligence. This innovative algorithm is designed to enhance the process of clustering by rapidly identifying mass and distance peaks, thereby facilitating autonomous clustering without the need for human intervention or parameter tuning. The talk clustering algorithm represents a significant advancement over traditional unsupervised learning methods, which often require extensive manual configuration and struggle with large data sets. One of the standout features of talk clustering is its ability to operate independently, making it particularly valuable for applications involving vast amounts of data. Its efficiency in handling large datasets positions it as a potential game-changer in the realm of data analysis and machine learning. Extensive testing has demonstrated the algorithm's robustness and effectiveness. It has been rigorously evaluated across 1,000 diverse datasets, achieving an impressive average adjusted mutual information score of 97.7%. The AMI score is a critical metric that assesses the quality of clustering by measuring the agreement between the predicted clusters and the true data structure. In stark contrast, other leading clustering methods typically achieve scores in the 80% range, highlighting the superior performance of talk clustering. Dr. J. Yang, the lead author of the paper, highlighted the uniqueness of the talk clustering method, which is based on the physical concept of talk. This approach enables the method to autonomously identify clusters and adapt to various data types regardless of their shapes, densities, or noise levels. Its adaptability is particularly important for real-world applications, where data structures and complexities can vary significantly. Unlike traditional clustering methods that may struggle with irregular data distributions, talk clustering remains effective across diverse datasets. By leveraging talk principles, it offers a more flexible and robust solution for analyzing complex data patterns. This makes it valuable for applications in fields such as machine learning, big data analytics, and scientific research, where clustering large and varied datasets efficiently is essential. Dr. Young emphasized that this ability to handle different data forms with ease sets talk clustering apart from conventional clustering techniques. The implications of this research are profound, as to clustering could redefine our understanding of clustering techniques and their applications across various fields, including data mining, image processing, and beyond, by eliminating the need for parameter tuning and enhancing the algorithm's ability to manage diverse datasets. Talk clustering paves the way for more efficient and effective data analysis, ultimately leading to better insights and decision-making in numerous domains. The concept of talk clustering is rooted in the fascinating dynamics of how galaxies interact through gravitational forces when they converge. This phenomenon is not merely a cosmic spectacle. It serves as a metaphorical framework for understanding complex systems in our universe. At its core, this idea hinges on two fundamental principles: mass and distance. Mass represents the quantity of matter in an object, while distance refers to the spatial separation between entities. Together, these elements create a powerful link to the laws of physics. The implications of this research are profound as to clustering could redefine our understanding of clustering techniques and their applications across various fields, including data mining, image processing, and beyond, by eliminating the need for parameter tuning and enhancing the algorithm's ability to manage diverse datasets. Talk clustering paves the way for more efficient and effective data analysis, ultimately leading to better insights and decision-making in numerous domains. The concept of talk clustering is rooted in the fascinating dynamics of how galaxies interact through gravitational forces when they converge. Talk clustering, as a novel unsupervised learning technique, has the potential to propel advancements in general artificial intelligence, particularly in fields such as robotics and autonomous systems. By leveraging the principles of talk, this method aims to refine the way machines perceive and interact with their environments. It enhances their ability to move, maintain control, and make informed decisions, thereby improving their overall functionality and adaptability. The ambition behind talk clustering is to fundamentally alter our understanding of unsupervised learning. Traditional methods often rely on predefined categories or labels, limiting the scope of machine learning. In contrast, talk clustering seeks to foster a new paradigm where artificial intelligence can operate independently, discovering patterns and relationships within data without human intervention. This shift could lead to the development of truly autonomous AI systems capable of learning and evolving in real time. To facilitate collaboration and innovation in this field, researchers have made the open-source code for talk clustering accessible to the broader scientific community. This transparency encourages experimentation and refinement, allowing other researchers to build upon the foundational work and explore new applications. What led to creating talk clustering artificial intelligence has rapidly evolved over the past few decades, moving from simple rule-based systems to advanced machine learning models capable of performing highly complex tasks. At the core of many AI advancements is the ability to recognize patterns and group similar data points together, a technique known as clustering. This method is fundamental to AI's ability to learn, adapt, and make intelligent decisions. However, clustering is not a new concept. For years, researchers have relied on traditional clustering algorithms such as k-means, hierarchical clustering, and dbScan to enable AI systems to process and analyze data effectively. While these techniques have been instrumental in advancing AI capabilities, they have significant limitations that prevent artificial intelligence from achieving true autonomy. A new technique known as talk clustering is now being hailed as a breakthrough, offering a more dynamic and adaptive approach that significantly improves learning speed, decision and adaptability in AI systems. Unlike its predecessors, talk clustering allows AI to refine its understanding continuously, make independent decisions in real time, and adjust its knowledge without requiring retraining. To fully appreciate the impact of this revolutionary approach, it is important to first understand the strengths and weaknesses of traditional clustering techniques and how talk clustering overcomes their limitations. One of the most widely used clustering techniques in machine learning is k-means clustering. It is a relatively simple and efficient method that works by grouping data points into a predetermined number of clusters known as clusters. Each cluster is represented by a central point called a centrid, and the algorithm iteratively refines these centrids to minimize the distance between the data points and their respective cluster centers. K-means is widely used in customer segmentation, pattern recognition, and image analysis due to its speed and efficiency. However, despite its strengths, k-means has several critical drawbacks. One of its biggest limitations is the requirement to specify the number of clusters in advance. In real-world AI applications where data is constantly evolving, it is impractical to define a fixed number of clusters beforehand. Furthermore, k-means struggles with complex and non-linear data structures. It assumes that all clusters have a spherical shape, which is rarely the case in reality. Additionally, it is highly sensitive to outliers, as a single extreme data point can significantly distort the clustering results. Hierarchical clustering is another widely used method that builds a hierarchy of clusters, either through a bottom-up elomerative or top-down divisive approach. In elomerative clustering, each data point starts as an individual cluster, and these clusters are progressively merged based on their similarity until only one remains. In divisive clustering, the process works in reverse, beginning with a single large cluster that is gradually split into smaller subclusters. One of the major advantages of hierarchical clustering is that it does not require the number of clusters to be specified in advance. It also produces a tree-like structure known as a dendrogram, which provides a visual representation of how data points are related. However, despite its advantages, hierarchical clustering has significant computational limitations. The method becomes impractical for large data sets because of its high processing requirements. Once a hierarchical model is built, modifying or updating it with new data is extremely difficult, making it unsuitable for AI applications that require real-time adaptability. Additionally, the computational cost of hierarchical clustering makes it inefficient for large-scale machine learning tasks. There are many given these limitations. Talk clustering emerges as an advancement in AI learning and decision. Unlike traditional clustering techniques, which rely on static models and predefined rules, talk clustering is designed to be highly dynamic and context-aware. One of its most significant advantages is its ability to improve learning speed. Traditional clustering methods require AI systems to be retrained from scratch whenever new data is introduced, which is both time-consuming and computationally expensive. Clustering eliminates this problem by allowing AI to refine its understanding in real time without requiring complete retraining. This continuous learning process makes AI systems more efficient and capable of adapting instantly to new information. Another major benefit of talk clustering is its impact on decision AM. Unlike K-means, which forces data points into rigid clusters, talk clustering allows AI to understand context more effectively. If you've made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.